Yo, what is good? Okay. What's up, guys? I just woke up a few minutes ago, and now I'm going to probably read some of the news that's going on, understand a little bit, and also read through some of the Python docs. So read through the news, understand what's going on today. Reading the news and cause MCs. Where do they have cause MCs? That looks questionable, I'm not gonna lie. Menu. Ooh, location. Oh, okay, there's just one in Illinois. Social media controversy. Yeah, my girlfriend has been telling me about. I feel like I have an account. Yeah, let's do an account. Yeah, I'm curious. Okay, interesting. Let me sync my cards. Okay. Master deck. Okay. Create a new deck. Just call it News. Create deck. News. Call 2023. December 20th. Also, I think the 5 things you should know. Second, Donald Trump has some bar from Colorado State primary ballot. Okay. What's next here? Where is this? Okay. Interesting. So, so what is going on there? Let's see. Global shipping industry might be affected, negatively affected by this is currently facing what are the people called? The Houthi Islamist political and military organization. Yemen. Are striking hacking commercial ships that travel along the Red Sea. US is planning to launch military strike against them to protect trade in the region. Military strike against them to protect trade in the region. Okay. Move. So this could lead to less economic activity / shipping activity and possible price increases due to Market cap 35 billion. I'm surprised Google has this. The little stock tip, I guess. It's Prologus. occupancy rates are not recovering to pre-pandemic levels. Occupancy rates are not recovering to people are not to office. Most office spaces are not at full capacity. Allow employees from home some days. Castle systems. Yeah, what is Policer.ai? Blah. Huh, okay. 5 pizza chains. Pacer AI, and there's also Castle Systems. Oh my god. Property technology solution. Office vacancy rates are likely higher than 10% forecasted to grow to 17% by 2026. CoStar. The delinquency rate of bank loans and loans converted into commercial mortgage-backed securities currently is over. Landlords are facing increasing pressures due to the loss reduction in rent income, high interest rates, and a shifting work culture that is causing higher defaults. These landlords have the option to sell their give them back to the creditors. So the current state of the housing market as of publishing it below, what is the outlook for WSJ? So occupancy rates are not recovering to pre-pandemic levels, meaning that people are not returning back to office. And most office spaces are not at full capacity, and more than half of the companies in the US allow employees to work from home some days of the week, and around 50 to 60% of them actually return to office. Place are high. Castle Systems office vacancy rates are higher than 10% and are forecasted to grow to 17% in 2026. CoStar and landlords are facing increasing pressures due to the reduction in rent income, high interest rates, and shifting is causing high defaults. Might use the bathroom. Maersk. Oh shoot. Oh, nice. Okay. I think what I'm gonna do now is probably use the bathroom, read through the Python docs, and then I have a call with Rudy at 9:30 for more Leetcode problems, so that'll be exciting. Yeah, I'm gonna use the bathroom real quick. Back, and I got a snack. Back, and I got a snack. Whee. This needs spill though. Some of these Four Seasons napkins. Okay, nice. What? Python. So this is control flow tools. When iterating through when iterating through a collection that is being modified. The more straight forward approaches. So I think one would be to loop over a copy of the collection, to loop over copy of the collection, so creates a new collection. Users that copy that items. Many ways that what is an iterable? An iterable is an object that's has successive items till supply is exhausted. Takes Rudy. Successive items in some type of sequence. Actually, we can input these iterables into functions and constructs. Will iterate or go through each of the items one by folder or something to come back to. Is a match statement. definition pairs its patterns and let's see. Oh, Rudy's on. Let's see. Okay. Yo, what's up, Rudy?
Hello, can you hear me?
Yeah, I can.
Oh,
Is
okay.
it okay if I also live stream today too?
Yeah, that's fine.
Let's go. All right.
Forgot what we were talking about the other day. I think we were doing the problem with
Adding two
with
strings.
yeah, adding two strings.
Or
So
not strings, I think. Just add two numbers in linked
add
list.
two numbers given to us in the form of a linked list, right? Let me do a share screen here. So the code was very simple ultimately. Basically what I didn't also finish it because yesterday I just fucked off. Like I did not do shit after 1 p.m.
Yeah, it's
Um,
okay.
but yeah, basically the idea is this. You can call this, well, first of all, we would get this function add to list one, list two. We check to see that if the length of list one is equal to the length of list two. If it is equal, then you just run this regular function, no problem, right?
Mm.
Otherwise, you have your false branch right here. And in the false branch, we have another if case, right? So if the length of list one is greater than list two, then we'll just append the zeros to L2. Otherwise, we'll append the zeros to L1. And that's it. I also just have to finish making the append function. But if you look at the add two numbers function right here, so like if we go into racket
Mm-hmm.
and just copy and paste this, and then you do add two nums like list 1, 5, 8, and then list 9, or I guess let's do something like this. It works.
Nice.
It also includes the carry bit, and you were right with what you said with the carry bit. So I kept thinking about this wrong, so I drew it out on a whiteboard.
Mm-hmm.
And basically, when we add two numbers, you just have to keep track of two things. Well, I ended up keeping track of three variables. So here we use let star to define some variables. And all that this let star does is like you let x be equal to this value. You let c be equal to this value. You let num be equal to this value. That way you can use it later here. So like you see c here, and you also see num here, right?
Mm.
So basically, the first thing that I did is just add the two numbers and save that result in a variable called x. And then the next thing that I did is figure out, okay, what's the carry bit supposed to be?
Right.
It's either going to be 1 or 0. So it's going to be 1 if x is greater than or equal to 10. Otherwise, it's going to be 0. And then for the number, you basically just have num um if 10 is greater than or equal to 10, then the number to add will just be x minus 10. So like when you have the case of 9 plus 9, that's 18. And so the only number you have to append is going to be 8 because the carry bit is 1. So that's where you would get this from. Otherwise, it's just x if it is less than. So like if you do 3 plus 4, that's just 7. So that's all you have to append to the list.
Mm-hmm.
So that's all that the number is for. And then that's all that the carry is for. And then this is still pretty much the same. If the carry bit is greater than 0, then you're just going to cons 1 to the new list. Otherwise, you're just going to keep the new list. So, yeah, I think that was pretty much that was the only part that required some thought.
Okay. Nice.
Yeah, so I guess do you feel comfortable with it? Like with all this code here? Because it's only like 14 lines of code.
I think
Really, really less even, because like usually what I like to do is this. But go ahead.
it kind of makes sense. It kind of makes sense. I still don't fully understand the racket stuff, but I think the process that you were talking about makes a little bit more sense.
Yeah.
Yeah.
So what do you want to do today? Work on another Leetcode problem?
Sure, I'm down.
Okay. Let me see. I don't know if I remember my Leetcode password, but let me check. Did you use a lot of Python? Oh, I'm already logged in. Did you use a lot of Python in Intro to AI?
And machine learning. I don't
Machine
think.
learning.
Yeah.
You did?
Mm-hmm.
Okay.
Okay. I think I might come back to this. All right.
So what problem did you want to try to do?
Hmm. I think. Here, let me. There's the Leetcode roadmap, whatever it's called.
Oh, Leetcode.
Yeah.
I forgot about Leetcode too. You told me about that.
Yeah.
Oh my God, I keep confusing that with Leetcode.
No, no, it's okay. It's okay. How about this? I'll send it to you real quick.
Okay. In the Zoom chat?
Yeah.
Okay, how do I look at that?
I'd
Which
say if you look at the Leetcode 150 on the top,
150?
or we could try the blind 75. That's just less than.
Which one?
You're gonna start up at the very top.
Arrays and hashing?
Uh, sure.
Okay. What is this? Contains duplicates? Oh, and
Okay.
we gotta code it in Python.
Mm,
I'm not
maybe.
too familiar with the Python code, but
I
I'll
don't.
try to have.
Yeah, I don't think you need to. And maybe you're
So
just suggesting that you do.
contains duplicates.
I think
Oh
that
wait,
one.
is Leetcode part of Leetcode?
Huh?
Is Leetcode part of Leetcode?
I think. I don't think so. I think it's just a guy that ended up doing some Leetcode stuff and just branded himself as Leetcode.
Okay,
Yeah.
let me see here. Okay, well, I mean, I guess if we're still allowed to use Racket, I might as well try Racket.
Yeah. This one I think is.
It says easy.
Yeah, I think we could skip this one, honestly.
Okay,
And try to do one of the harder ones.
which one?
Let's see. How about the longest consecutive sequence, the very last problem in that? I've never seen this one before. Given an unsorted array of integers nums, return the length of the longest consecutive element sequence. And we have to write an algorithm that runs in big O of n time.
O of n times?
Oh,
That
wow.
seems. Hmm. Yeah, that seems a bit tricky.
Yeah, this one sounds pretty hard.
It's not fun when I'm winning, though.
Nah, sir. Wait, what is the longest consecutive element sequence?
I think what they mean is like if this is supposed to be sorted, I'm assuming this is what they mean 1, 2, 3, 4,
Mm,
and then 4 isn't next to 100, and 100 isn't next to 200, so those wouldn't really be consecutive elements.
mm-hmm.
And same thing like with right here 0, 0. Well, I would assume this is supposed to be output 9 because 0, 0, 1, 2,
Oh, I see.
3,
Zero,
4, 5, 6, 7,
right? 8.
8. But that's
That's 9.
10 that I'm counting, so I guess we don't count repeats.
Okay, okay. Ooh, yeah, this is hard. Because I remember counting sort was big O of n, but we would have to create an array of the largest size. Or the largest number in the list, right? So that might not work. Yeah, I don't think it's gonna work. Ooh, this is hard, Rudy. This is really hard.
Now, I can think of maybe one way to do this. Oh,
What you thinking? What you thinking?
I was thinking we could just run through it once and we keep track. The thing is, okay, originally I was thinking, okay, what happens if we just set our initial variable to look out for to 0 or something like that? And because like right here we see, oh, 0. So then the next element that should be next to that should be 1, but that 1 is at the very end here.
Mm,
And then there's other elements in between. So actually what I was thinking at first won't work. So I might need a moment here to think about this.
yeah, yeah. I wonder if there's some mathematical relationship between the two. I don't know. One, two, three, four. Having a run in big O of n time is crazy.
Yeah, that's the biggest thing that's bugging me about this
In
one.
linear time?
I
Man.
mean, maybe you could eat.
I keep thinking about trying to sort it, but I don't know if that's the right way to think about it.
Yeah, because sorting would require, I mean, in this case, it's a very small thing to do because we're not really working with a whole lot of data, but already this is going to make it take a while to 200 here. Like here, it's not so bad, but here you're going to have indices going from 0 all the way up to 200.
Yeah,
So,
that'd be a lot.
yeah. So that's why you want to use counting sort here because it wouldn't be too reliable.
There's another, I remember, sort. Yes. Forgot what that one was called. That also took big O of n time. In some cases.
What, radix sort?
Maybe.
I think radix sort is about the same as counting sort.
But now you're looking at the digits.
Yeah. But I don't know if they necessarily want you to sort the problem here.
Mm. So if you have 100 plus 4 plus 200 plus 1 plus 3 plus 2. I'm thinking maybe what if we had two data structures? So one of them is kind of maybe this dictionary or hash map that starts that has a key which is the beginning of a sequence, and then every single time we iterates. It's tough actually.
That's what I was thinking of the hash map too, because I think I was know what you're saying. Like you wanna, so like maybe you might have 100 here. If it's not in the hash map, you might add it, and then you'll add 4 here. You'll see 4, it's not in the hash map, and then you'll add it, and you'll see that it's not. If you do find hash key -1, it's not in the hash map, but you also haven't seen it yet. And you do find key +1, 5, you won't see that. So you just add that, right? And then you get to 200 and you put that in the hash map. And then plus or -1, you don't have those keys. So you just put that in anyways. And then 1, you add it in the hash map. Plus or -1, you don't have 0, you don't have 2. So you just add it anyways. So basically the longest consecutive sequence is still going to be 1. But then once you get to 3, you add 3, and then you see, do we have key 3 plus 1, which will be 4? Yes, you do have that. Do we have key 3 minus 1, 2? No. So far the count at 3 will be 2, but would be 2 because of the 3 and the 4. But we don't have 2 yet. But then once we get to 2, then what you do is you look, do we have key 2 minus 1, which would be 1? Yes. So you add that to your counter, so that would be 3. And then 2, you check it, and you say, do we have key 2 plus 1? That would be 3. Yes, you do have it, so you would increase the count to 4. You see what I mean? I could probably code it up in Ruby.
Okay.
I gotta learn Python, but let me see here. Okay, so basically the idea would be this: you define on X, I guess, and then we'll take in the parameter of a list of let's just say nums. And then you do a counter is equal to 0, right? And then HMAP, I guess I think this is how you define it. And so now what you do here is for I in 0, nums dot length -1. I think this is the syntax for it. Okay. So we want to see if the current thing, if nums I, okay. Oh, hold on, let me look at my other reference for the, because I do remember we did something kind of similar a while ago.
Sure.
So let me look at the syntax for the hash map. Okay, so the hash map is right there. The counter is right there. Okay. We don't need to do. We also don't need the parentheses around the little function call here. Let me just make this simpler. Give me one moment here. So if we have the key, then we want to check to see if we also have n+1 and n-1. Since we're guaranteed that it's only going to be an integer.
豆子。
青豆就是那个在那个夹子呢。
Sorry, thank you. Oh, nice, you got.
马上要好了，这个。
Okay, 那我等一会儿再吃吧。Yeah. There's another key.
Okay.
Check if. I think you're right with the n-1 n+1 thing. That's actually game changing. Because yeah, that could help a lot.
Yeah, let's see if it works out though. I-1. Hold on. Okay, let's actually have to look at the correct indexes here. So we get 100. Okay. So let me look at this from the top up case. So if we have the number, then we're going to want to do comparison. Else. Okay, hold on. I forgot how to make comments in Ruby. Let me look at how to make, what is it? This could really be anything because this doesn't really matter too much, but Okay, so here we'll basically do val is equal to nums I.
It's the key.
Basically what this is saying, okay, the number we want to look at is 100, right? So we'll do 100. And now what we'll do is if hmap dot has underscore key of val minus 1, and we'll do counter plus equal to 1 for that one. And then we'll have another if. So if hmap dot has underscore key val plus 1, I'm hoping this works. We'll also do counter plus equal to 1. And at the very end, we should return counter. So to do a little test, to do a test run, let me see here.
Let me see if this works for you.
Yeah. Let me see here. Let x equal to, okay, we're not in brackets, so I think x is supposed to be equal to fun x. And I think this is how we make arrays in Ruby again. Let me just make sure.
I think so.
I think so. I think it's with the brackets. So let me just try it out. So if we say 100 for 201, comma 3, comma 2, and then we put x. I don't know if we put it like that, but let me see. 0, what?
Shit.
Okay. Let me make sure we're looping through it right. Hold on. Let me just check something. Okay, so we are looping through it right. 1, 2, 3, 4, 5, 6. Okay, so yeah, those are 6 elements. Okay, so that's right. Okay, so basically, maybe I'm doing something wrong with declaring the keys. Let me print out the hash map at the very end. So let's see what this does. So we have 100, we have 4, we have 200, we have 1, we have 3, and we have 2. Okay. So the hash map is okay. So let me see if we're entering in these if conditions here. Let me see here. Sorry, this is usually how I debug in code.
No, it's okay. It's okay. I'm also thinking about how I would do this as well.
So we're not entering in this condition here. I think.
Thank you.
Let me see if we're gonna enter in this one.
Okay. I'll take care of it.
So we're also not entering in the condition where.
Here's the keys.
把底下还有一个那个也插到上面了，这个地方插底下，这个灯。
That okay.
底下站上2个了。
Okay.
Okay, I think I see the problem here. I definitely do think I see the problem here. The problem is with how I declared this if. We're never entering in this if because I'm saying if hmap that has key nums I. We're never gonna enter that in because we're just checking. Oh, do we have 100? No. Let's add it. Do we have 4? No. Let's add it. Right.
Okay.
So my idea is I was saying, okay, do we have, okay, let's add 100. But, okay, so I think to rewrite it, it doesn't have to be too much. We don't have anything in our hash map, right? So what we have to do is we have to add the keys in and we have to check to see if we have the indices I minus 1 and I plus 1, but not indices, but you know, the values. I plus 1 and I minus 1. So basically what we're supposed to do is this, right? So you do hmap nums I just to initialize it to something, right? And now what we do here is you say val is equal to nums of I. So that'll be 100. And now what we do here is if hmap.has underscore key, and also let's just move that down, val minus 1, then we'll basically counter plus equal to 1, and hold on. Goddamn, I'm running out of time.
It's okay. We add the key n plus 1, then we create a new list. Add the list.
I think I'm missing an end somewhere. Okay, so basically let's just do this so that we don't get weird indentation, but basically what okay. So val is equal to numbers I. So if, okay, let me look at the syntax for the if again. So if hmap dot as underscore key question mark. This is a function call, so we say val plus 1. And we'll say counter plus equal to 1. And if hmap dot has underscore key val plus minus 1, counter plus equal to 1, end. And then we have to end the for loop, and then we have to, this should work now. Let's see though.
Alright. I'm excited.
So we're off by 1.
Oh, shit.
Let me see. Let me try to copy this and see if it works here.
Okay.
I think I realized why we might have the off by 1 error, but let me make sure. Copy that. Oh, goddamn it. I don't even know why I copied that because I forgot how to paste in Emacs.
I think you'll figure it. Shit.
I forgot it.
Yeah, me too.
Okay, let's do another one. Let's just say y is equal to fun x. Oh, dang, this was kind of easier with the Ruby than Racket.
That's a flex right there. Being able to do it with multiple languages.
Yeah, because I mean here it's easier to do the 8. So we're off by 1. I mean, I guess a quick solution would be at the very end to just do you know,
plus 1.
Plus 1. Yeah. And let's see here. 4 and 9. Did you want to submit this code on?
Yeah, I want to see. Let's see if this works.
Okay, let me see here. Where is it? Ruby. And this should technically run in whatchamacallit? Of n times because of that hash map data structure. Okay. Let's copy.
Right,
Paste that there. Let's run.
Nice.
Yep.
Alright, let's see if we submit it.
Okay.
Oh,
Wrong answer. 19 out of 75 passed. Oh shit. Input. Oh yeah, when we have empty.
Oh man, okay.
So let me just do one quick check here. If nums dot length is equal to 0, return 0, and okay. let's run that to make sure I copy paste it right. Now let's submit it. Oh, god damn it. Expected.
Let me see what happened.
1201 output 5, but it only expected 3.
Oh, shoot.
We're supposed to take into account that we don't have unique duplicates. I forgot that from the 0 here. But we're getting there. We're about to debug it.
Okay, I like it. Plus 1.
So now we have to see what happens if we have the same element already there, right?
Okay.
Let me think.
I think we could do numpsticked.
Yeah, I think that's why I was right at first, because I was checking to see if we have the key in the map.
Oh, man. Thanks.
Yeah, that's why we had to check to see if we had that key in the map first. Because if we already have it in the map, we don't want to double add stuff.
Okay.
So let me think here. I think one thing we could do here is, I'm not sure if this is going to be a quick fix to it.
Else.
That's the thing to continue on to the next iteration of the loop.
Mm-hmm.
But let me see. Continue. Hold on, let me just quickly Google search this. Okay, next. I appreciate these programming features that Ruby has now, dude.
Nice.
After doing compilers, I can't imagine how hard it would have been for someone to compile all this stuff.
If the dictionary has the key n-1, then add the value to the list. What's the key n+1? Then we grab your key.
So I copy that. Oh shit. I think that's copy.
I'm not too sure if the way I'm thinking about this is gonna work.
What were you thinking?
The dictionary stores the keys, and then the keys will be the actual numbers in our list, but the value is going to be a list of numbers that come after it that exist within the parameter list. But I don't know if that's the right way to go about it.
Wrong answer. Oh, god damn it. Almost. We got a little bit more of the test case passing.
Dict dot keys num-1 and num dict dot keys. The problem could be when we have, say, element words. Our last element is 8. That connects to elements. Call these.
It's kind of tricky.
Yeah, I think it's a little bit harder than we think it might be.
Yeah, because I keep getting +2, +2. So I mean, ideally, I'd like to say, oh, -2, but that's not going to work because then it's not going to work for our initial cases. So I'm thinking
So we got through that. Then our dictionary. First, 1, 1.
What's the longest sequence here anyways? Because I don't see a 0, so I see 1. Okay, I do see the 0. So -1, 0, 1.
Do we create a new key?
But I don't see a 2.
起来吃饭了。好
So
了。
5. Okay, 4.
啊？
Okay.
哦，那你就累了，你不喝吃了算了。
4, 5, 6, 7, 8, 9.
干嘛了他？昨天我都不知道什么时间是。
哦，不知道。
吃饭了。
Oh no.
嗯。
Okay. So be added, and let's say we have 7, 6. So we have 5. So 1, 2. Under this logic, it'll be 1, 2, 3, and then 5. We would just create a new one, just 5, and then 4. It'll be combined 2 lists. Right. The next smallest, right? Oh man. Right, so that's why this wouldn't work, because how do we know what the n minus or the next smallest would be? Because we don't know what to do with 4. N minus 1 doesn't exist, but we already have this sequence here, so I think, let's say we create a key for every single element, and then a list. So it'll be 1, 2, 3, 5. Right, so let's say we do create an element, we also append the element in this list, and then we append the element in this list, and then we 5, so 4. Oh, what if we also append this? So it'll be 1, 2, it'll be right, it'll be 2, 3, so 1, 2, 3, 5, 5 doesn't exist, 4. Oh right, I think we would want edit everything before it. Right, I think we would want 1, 2, 3, and then 5. We could append. So for every single one of them, we would want to include Yeah, this one is hard. This one's difficult. I think the meeting ended. I'm gonna eat dinner or breakfast real quick. Okay, so I think I'm gonna go eat breakfast right now. Kind of giving up on this problem for right now. I think maybe if I have some time later, I might go through it and think about it a little bit more. All right, bye.